And you can see here I have the ability now to break them, which is completely realistic, right? Okay, so update, I have fixed this collision. So as you can see here, there's lines kind of in the middle of here, sort of aligned with the top of this hole, like here. These are the faces, the sides of the box colliders. So somehow all of these were like, had these, all of their box colliders fit to the sides of the model. Maybe one of them was like that, and that's the one I started with here. However, we're also going to need to do this for this one, this one, this one, and all of these. So one thing, if you want to save these settings on each of the box colliders, here is how, one way that you can do that here. Click this option here, this sliders icon, and this will bring up a window, select preset. You can also save the settings preset to a file in your project. So, one, and save. Let's also make a folder presets. Just collapse some of these things as well. Drag this in there, and basically do the same thing with this one. Save current to, box collider 2. Right, shift select these other ones, drag them, oh no, not prefabs, presets. And from here, we can load from them. One way that we can restore like the settings of all of these 4 box colliders on all of these is to click the wooden post and right click on the one that actually has the settings we want, and right click on it and select copy component and select all of them and right click and hit remove component and then paste component as new. As you can see here, there's one of these colliders that is like actually correct. However, I don't really want to do this way because I don't know which one is really which. Also, we have the preset, so I'm going to click again the sliders icon and choose box collider 1. And again, all of these have the same settings, so they can be multi-edited. Even if they don't have the same settings, they would just have like display 2 dashes or something here, but they can be multi-edited. You can like type in something, box collider 2, slider icon, box collider 3. This is a good way, if you're using box colliders on a component that have different settings, this is a good way to like keep that setting in case like you change the geometry or modify the geometry or something of the object. Okay, so now that we've done this to all of them, let's go ahead and select the terrain and re-enable it because we want it to be enabled again. And also it's looking completely black here, so let's go ahead and click this, draw mode, and choose shaded. And this will display it in the shaded view, and as you can see here, it's looking, well, pretty nice. So let's see how it works. Okay, so as you can see, some of it's working. So the majority of these chains are actually working. However, you can see that one of these, I think it was this one that was having issues. So as you can see here in the scene, it's the third one, no, the fourth one. I can see which one. I don't know exactly how far it is, like 3 spaces from like the right end here. So now I probably want to edit the position of this. Oh, you can definitely see there's a mistake. The chains are definitely offset here. So we can move this. So if you're having issues, this is a good way to like troubleshoot here. And as you can see here, we now have like this part of the chain more aligned with the hole, which we modeled around using the box colliders. Of course, we could have used mesh colliders, and that would automatically take care of this for us and make the chains collide with this. It actually does work. However, it uses the whole model, whereas box colliders are just a few primitive colliders, just a few cubes. And you can't see the collision nearly as well as you can the modeling. So as you can see here, we have our chains. Another thing here is that we're definitely quite a bit shorter as the character than these chains are. I did scale down these posts for the terrain, for the chain simulation, and even the chains I scaled down. However, the first person controller, that I didn't scale up. I made it taller in the simulation, the final simulation. I'm going to scale this on the y-axis by 1.5. Let's try that first. And you can see here it's a bit more accurate to how it was. And also, in the final simulation, like last time, I definitely was able to more push the chains. Sure enough, this does have a physics component, and I'm going to try increasing the mass of this to something like 5, and this will just make it a bit stronger. And also, I mean, these chain links as well definitely have like their mass set to 1 by default, but because we scaled them down, might want to set them to like 0.1 or something. Also, might want to select maximize on play, because that, again, matters a lot more when you have like a larger game, which is definitely apparent here. And you can see here I have the ability now to break them, which is completely realistic, right? We can of course also set a bunch of different things for this first person controller, like the walking speed, running speed. You can like hold down shift or something to run, and like the jump force, stick to ground, gravity, the sensitivity of the mouse look sensitivity. I found this like too low, definitely. So I'm gonna set this to like maybe 8, and I want to set this Y sensitivity to something lower. So like, and also clamp vertical rotation. That means that your camera can only get to like 90 degrees and there's no more rotating downward. You can't rotate any farther downward or else it'll kind of be inverted. Minimum X, oh, so X rotation. So it rotates like downward and upward. That's the X rotation. So this is what those values are for. It's tied to this. Clamp vertical rotation, smooth, and like smooth time. This is like the interpolation they use for like the looking around effect. Lock cursor. So this basically like locks your cursor to like the window. I don't really know what FOV kick is. I think head bob is like that weird effect, like your camera like moving up and down or something. You can change like the curve. Jump bob. Don't really know what that does. Step interval. I think this is like for controlling, I think this is for like the time in between steps. And like you can also set footstep sounds and jump and land sound effects. You can see it's very different. Specifically the smooth, like the interpolation effect as I look around here is like way too like interpolated to me. Maybe 2. Let's see what this does. I don't know if it's going to be like inverse. That's even worse. So it's definitely an inverse effect or something. Set this to like, so yeah, set this to like 10. Set it higher if you're finding it like too much. One thing I also did to this chain simulation scene before I took the screenshot that I uploaded to Pinterest and also the Unity forum thread that I posted the object cloning iteration setup here is to change the angle of the lighting. So the way you do that is to change the angle of the directional light, the rotation of the light. You can set the Y rotation to something. Setting the Y rotation will basically do this. It'll change the rotation on the up axis. What I changed though, the shadows were maybe about this angle initially, and then I changed the X rotation to be not as high, so you can kind of make it look like a early morning kind of thing, and you can see the skybox is like changing. It's kind of like sunset, and also when you change this, there's this kind of this white circle that moves. So this default skybox is really impressive actually. So yeah, this is one of the things that I did before I took a screenshot of the image. And you can see from this angle, it definitely looks very similar. One thing I also did is to make the light rotate in real time. For this, go to Add Component and select New Script. Open this. And now first of all, we want to create a variable for how much we want to rotate it. Public, and this means that we can access this in the inspector, vector 3 speed. So this is a 3-directional value that will rotate the light. Now, we want to delete the start method. I don't think we need it for now. And in this update method, we want to rotate the light. For that, in the update void, we can use a function called transform.rotate. This is a function that is used to change the rotation of a game object. We can put in speed times time delta time. The time.delta time is for keeping the time, the speed of the rotation consistent between different refresh rates for different platforms. So now when we build this, okay, so semicolon needed at the end of this line. Definitely make sure that you do that before building. So yeah, other than that, we should not get any errors if we do anything correctly. Now, let's move on to rotating the light through the script. So the good thing about using a vector3 variable to rotate a light or to move something, you can move it on any axis by changing these variables in the inspector. So you don't have to change these to choose a different direction to move it in or rotate it in. So we're just going to experiment with this firstly by rotating the light and seeing how these shadows react to us rotating the light. So we obviously kind of want this to happen like in this direction. So this means that we want to add to the x value of the rotation every frame. And of course we do this using the script. Hit play and test this at 1. This is a bit slow, so 10. Let's try that. Hit play again. And you can actually see here that it's actually moving. Okay, let's try 50 just to really emphasize this. And this looks a lot more like a time lapse now. I mean, this looks like a time lapse anyway. You can also see this moving. My mouse is stationary right now, and you can see this like white circle that kind of emulates the sun, I guess, moving. And as it rotates, the skybox becomes black, and it just kind of to emulate nighttime. So this default skybox is actually really impressive. Of course, not that it looks like the best skybox in the world. Like the default skybox is just a gradient looking, just kind of weird looking skybox. Obviously a AAA game or something would have like clouds or something, like a actual skybox like with texture, like actual clouds or something, or like starry background. So of course many games definitely do have that. As you can see here though, that's how I got the light to rotate in real time and react. So like it emulates the sun. It emulates how the sun rotates and how shadows move. Let's try 25. And obviously this is not a photorealistic scene. This kind of, it really evokes the sun. And I guess I'll just show you one thing we can do as well. To decrease the amount of time it actually calculates the shadows, we can actually change the void to be IEnumerator, and we can rename this to custom update. Then we can create a public variable, float variable, update rate. The next thing that we're going to do is to add a line before this. You can see like there's some kind of red underline. Let's add a line before this that the coroutine, the IEnumerator needs to actually be valid. So what we actually need to write here is yield return new wait for seconds in this case. And then we can input update rate, and that's the float variable, and this will wait for the amount of seconds that we put into the update rate in the inspector. Oh, and we also need to multiply the speed with the update rate. So what it's essentially doing is that it's waiting this amount of time to do this. Oh, and then we need to also start the coroutine custom update. So what it's doing is it's recursively starting this coroutine. Oh, and we also need to bring back the start method and start the coroutine here. So what it's essentially doing is it's waiting this amount of seconds and then multiplying it with this update rate. So this way it does not matter what we change the update rate to, it will not affect the speed. If we were not to multiply this speed with the update rate, it'll rotate it like a different number of times per second. And if we didn't multiply the speed, it rotates every single iteration with the update rate. It will essentially, changing the update rate will affect the speed. However, because we're multiplying it with the update rate, it doesn't matter what we change this to, and we can control how many times it actually rotates each second. Why is this important? In real-time lighting, you want to have, first of all, the mode not set to real-time, but mixed. And what this is going to do is when the light rotates, it'll have it set to mix. So if it moves, if it rotates, basically, it will calculate the real-time shadows on the frames that it is actually rotating. The rotation of the light is different because the direction that it's pointing is different and it's casting different shadows, different shadow angles. So only when it moves is it important. So we can control the resolution, how many times it rotates every second. So in between these, it does not need to calculate lighting. One thing we need to note though is that it rotates the light every this amount of seconds. So this isn't the rate. If we were to increase the variable to like this amount, as we keep increasing, it doesn't really, it's not that it increases the amount of times it is iterating each second. The rate is not higher as you set it higher. Changing it to 0.1 would rotate it 10 times per second. 0.01 would update it 100 times per second, so that's really high. So probably 0.1, and this also depends on the speed that you're rotating the light, because if you were to make the light really slow and not this like sped up thing, if you were to like slow down your day and night cycle like this, then you wouldn't need to have this set like to a high update rate because it's moving really slowly. And so you might not be able to see it as well when it actually rotates, when the shadows, you wouldn't really be able to see that stuttering effect because it's moving so slightly.